So yeah, thank you everybody for coming and listening today. We are Team 16 with the Senior Design Center at NC State. We're working with PRA Health Sciences this semester on the Replay Honeypots system and product. This is phase 3 of the system. So we're the third team at the Senior Design Center here at NC State to work on this project. When we got the project, it was a fairly bare bones system that had some security issues and some scalability issues, but mostly was a proof of concept of the idea. The goal of the system and that idea that was proofed in those earlier phases was to securely and at a large scale mimic the behavior of a company's infrastructure and business applications to bait attackers who have access to the internal network and track those attackers to determine their reach, skill set, intentions, and be able to better prepare PRA or other companies who use this open source project to prepare them to battle attackers. So if you're not familiar, the concept of a honeypot is exactly that, baiting the attackers by looking exactly like some other application server, whether that be a file server or an SSH box or a database. We want to look on the network exactly like those servers without actually having to run the applications, which are computationally expensive and needless comparatively to the actual applications. So if we want to move on to what we were doing in our phase, we can go ahead.
Yep. So some of the things we're required to do are role-based access control. That's a new feature that we needed to add. That would help with security. We have the configuration generation tool that will create configs for the honeypots. We have the database extraction, which separates the management from the database from the management, which was a new feature. We have SAML authentication, just another way to log into the system. We also have honeypot monitoring, which will a new feature that will show all the metrics for the honeypots, and HTTPS.
Okay, now we can go through sort of the overall system architecture and the design diagram in the middle of your screen. So first of all, we have the honeypot, of which there could be many in the system. One of our requirements is make sure we could have thousands of those without issue. And basically that's going to communicate with the database that you see in the middle. And it's going to send logs and alerts there for if it gets scanned by an attacker. And also it's going to watch the database to see if it needs to reconfigure itself. And what we mean by reconfiguring is the config determines what applications it appears to be running on the system. So it'll watch to see if that's been changed, and it'll bring down the applications it currently has and then stand up new ones. We also have the rogue, which is not necessarily a software component we've added. That's just modeling an attacker. So it's one of our systems we use to attack the honeypot, and it's going to do what we call an Nmap scan, and that's going to go through all of the ports on the system and try to determine what applications are running on it. So one of our main goals is to try to fool that scan into saying that we're running certain services even when we're not really. And the way we do that is in response modeling. You can see a little blurb about that on the right. So what we do is we capture all the packets that Nmap sends, and then we put that in our configuration so that the honeypot can know how to respond to those packets and it look like a real server. And we also have the config generation tool, and that's basically what that does. It brings in the Nmap scan results and the packets that come across the network, and it generates a JSON document that you can then upload to the honeypot, and that will determine how it replies and what services are running.
Speaking of role-based access control system, a user can choose to log in as a default admin user or default editor user. There's no much difference between those two roles, but there's also a default setting, which is default auditor user. A default auditor user can only have read access to all front-end pages, but the admin and editor can have both write and read access. After they logged in, they can choose to communicate to they can choose to view the data through the REST APIs. We used get, delete, post, and put REST APIs to make sure their operations are legitimate. And user also can choose to log in through the SAML, as mentioned before. Generally, there are two security improvements. The first one is separation of database and using a REST API to make sure the operations are secure. And the second one is replace all HTTP traffic to HTTPS. The next part will be testing.
So some of the testing that we had was interface testing, which was done through Selenium, about 30 test cases that covered half of the interface. We have honeypot testing through integration testing, covered about 65%, and API testing through Postman that covered 60% of the API.
So now, do we want to go through a live demo of the system?
Yeah, so we can start. Does anybody have any questions following that up? Any questions about the project, the scope, our tasks this semester that we want to follow up on?
It all looks very nice. What was the most difficult part of the project?
Any thoughts on that, Stu?
I would say mostly just various technical challenges we faced. One of which was setting up HTTPS in a development environment. So normally in a production system, you would have an actual signed, validated certificate for HTTPS, but in a dev environment like we had basically fake certificates, so they were self-signed, they weren't really validated, and that causes a lot of issues with different frameworks and different languages. So getting that working with self-signed certificates was definitely a big challenge for us.
Yeah, and I would follow up. One of the biggest things here is that we are running this all on Docker as an architectural solution. So the idea is we have one management node that manages the entire system, and then we would have a number of worker nodes that have any number of honeypots that run on them in small containerized Linux installations. And Docker is intended to be a microservices solution to talk in between containers across nodes, not necessarily to join a large number of Linux machines to the host network as if they're actually connected to the host network. And that's what we need. We need these honeypots to appear exactly as if they are on the network. They are a network entity just like any other device on your network. And fighting that battle to make Docker do something it's not inherently built to do was probably the hardest thing that I ran up against in this project.
Is there a reason why Docker was chosen, or was that already the basic structure of the project before you got it?
We were given a set of technologies coming in, and we were asked to stick to them. So CouchDB for our database solution, Docker for our architecture, and a couple Python packages for how we're handling packets. So.
Okay, so is this designed to run in a single infrastructure, or can it be multi-cloud provider hosted? For example, could this Docker containers are supported by all the major platforms? Could I set this on Google, Amazon, and Azure all and run it across multiple platforms?
Any thoughts there, Steven? Or Lagni or Sue?
My gut is saying that you could. We had only tested it on machines that were on the same internal network, though. So
yeah, given the correct virtual network, I don't believe there's any platform limitations here. It's entirely dependent on publicly available Docker images, and then we build upon those with a local build script and step setup. So I don't see why it couldn't be.
So as long as you could VLAN the infrastructure, you should be able to do it.
Yes.
Very good.
Any other questions from anybody else or follow-ups? Okay, looks like we have one in chat. Let me pull up chat. Okay, so we have a question. What are the typical benchmarks for coverage? Is the 50 to 65% range common for testing? So Lagni or Sue, you guys want to field that one since you've been working on testing this week?
Yeah, I mean, at least for the web interface, our sponsors asked us not to focus too much on the front end. They wanted more focus on the back end part, API and the honeypots. So usually that's why we have more coverage on honeypot and API.
And I will add as well that these aren't like the best coverage numbers. Typically you'd want maybe 80% to 100% for really thorough testing. But that was one of the challenges we faced, is that putting testing as well as all the functional requirements we had proved to be a big challenge, because we'd added a lot in terms of functionality of the system. So as you add more functionality, the more you need to test for increased coverage. So that was one of the challenges.
Yeah, and we went from 0 to 100 on the REST API side during this phase. There was nothing in terms of custom communication between system components. It was all just front end talk directly to database via its expected methods. So we added a lot of new features and a lot of surface area to test. So we have been catching up in the testing department ever since we finished our main iterations. But for your question, is the 50 to 65% range common for testing? I think technically the recommended goal is that you should have 70% to make sure that most of your boundary cases are covered. You don't have anything big really slipping through the cracks. It mostly just makes sure that you're covering yourself a little bit. So we are a little bit below the recommendation there, and we've been catching up as we go. So. Anything else? Any questions from a couple people that came in late? Just anything you missed or so? If not, we do have demos that we can perform. We have quite a few system components and behaviors here, so we can let you guys kind of choose what you kind of want to see. We have demos around authentication and role-based access control and permissions. We can demo the honeypot behavior and Nmap scans. We can demo the config generation tool. So it's really up to kind of the group here. What you want to see first, everything is also a possible answer.
Does anyone have anything they're particularly curious about? Yeah. Everything is the answer. All right, so the honeypot scan takes maybe like 5 minutes to complete. So I will start running that in the background while we go through the other demos, and then at the end we can wrap back to that.
Yeah, we do perform Nmap scans at the scale of 65,500 ports. We scan everything possible, just for proof of concept, making sure that we detect scans, and making sure that we behave correctly at the Nmap level. So we do spend a little bit of time there running those. So we'll kind of multi-thread the presentation.
Lagni, do you want to start us off with a role-based access control front-end kind of demo?
Yeah, sure.
I think
yeah, do I have to stop sharing?
I think you have to stop sharing, okay.
Yeah. Okay. All right, so this is our front-end management server. I'm gonna log in as an admin since it has all the permissions. So right now it's showing some of the log distributions. You have the user's profile and they can change the password, do all sorts of things. So in terms of role-based access control, we can add new roles with sort of granular permissions to all the different management pages. So say I make a role that says that has like nothing, like like it has no access at all. Let me just add all that. We can also add so we have auth groups that that we can assign honeypots to. Right now there's only default auth groups. Just gonna add none. And then we create our role. And let's, so say I log into as a user that has, so our SAML user has only some access. They're an auditor, so they have only read access to users, devices, and configs. They have read and write access to roles, so they're allowed to add new roles. But they can't have, but since they only have read access to auth groups management, they can't add new auth groups. Same thing with users. So say I want to edit a user, it will say that we don't have write access to users. So yeah, that's how roles work. If Sue wants to talk about logs, let me
I
stop
can
sharing.
go through the SAML authentication logging and also logs and metrics. I'll share my screen. Can you see now?
Yes.
For the SAML authentication, first you click this button and it will navigate to the
Have to log out of the SAML provider.
Yeah, so we use one login as a federated SAML provider. So you'll have to go to, I just sent the one login link in Discord, by the way, so you can go there and log
yeah, I
out.
guess I can go through the matrix and admin log first, and then after I logged out on the one login, I will redo the demo on the SAML authentication login. Also, it's also the admin login at the admin account. First, it's matrix. Yeah, as you can see, these are the host name of Honeypots, and default shows the CPU usage, RAM, and storage. For the CPU usage and RAM, they're used as percentage. And the red text means this matrix is out of date. Only the black text shows it's the updated one.
Yeah, and we consider anything over 15 minutes to be a stale metric. So we kind of use the metrics as a heartbeat indicator.
Yeah.
Okay, so this begs the question, how are you generating your host names?
The host names right now, due to the networking limitations, are dependent on the host name of the host that's hosting the Docker node. So that's why you see repeats of Winnie and Yogi. It's because we deploy the honeypots out to the node. They get Winnie and Yogi because of our two worker nodes. And then when we redeploy, they have the same host name. So those are different instances of the honeypot from different instances of time. They just happen to have the same host name.
One of the
Okay,
maybe
so
potential.
how would this project forward if you were spinning up 1,000 of these?
With a slightly different networking model that would scale up, they would get Docker assigned host names, so they would be random strings that assigned to the Docker containers.
Okay,
And one of the
that makes sense.
potential action items in the future that our sponsors were interested in was being able to change the host names of the Docker containers so that you can actually have, ones that aren't random strings and are actually human readable. That's not something we did as part of our phase.
Okay, makes sense.
And you
Yeah,
see
also-
with
One feature of this table is you can sort every column by just clicking.
Did you consider filters? Oh, you got a filter by tag at the top. Does that filter, just config default?
I
Yeah,
don't
so
think we have any tags currently on the honeypots, but you can
Okay.
assign tags to them.
yeah, so you can assign any number of any strings to the honeypots and it counts as tags, and then you can filter in several places across the GUI by tag. So you could say this device is a North Carolina device, or this device is a Virginia device, or this one's in Raleigh and this one's in Durham, or anything you really want to extend that system out to be. We had it traditionally locked down a little bit more to be like you could have a geographic tag or a system-based one, but we just went with you can have any string.
Currently, why you saw config default in there is that what we do is we auto-generate a tag for whatever config the honeypot has. And that way, if honeypots are running the same config and thus are acting the same way, you can group those in the front end.
This is example of the config. Also, the next feature I'm going to demo is admin logs. For example, if some user they add a new row or just delete honeypot, it will be recorded in this admin logs page.
Yeah, we have a slight bug there with the date. I don't think any of these changes were made in 52,839. It's a calculation error. We've been working on that one for a little bit.
Purpose for this is just to provide that extra security so admins can log in and see if anybody's been doing anything sketchy with the system.
I'm finished with demo, and I will fix the SAML authentication and we'll re-demo it later.
So, Stephen, how are we on the Nmap scan?
Check. The Nmap scan is complete.
Okay, cool.
So I can go
Let's
through
show
that.
that off. Yep.
Right now I'm SSH'd into the rogue VM that we showed in the diagram. So just for sending off the scan. And you can see it goes through every port 0 to 65,535, all the ports that are available. And it goes through and determines what services are running on each port. And the current config this honeypot uses has an SSH service running on 2201. Well, it's not technically running, but it's pretending to. Go to 2201. Interesting.
Gotta love Nmap, not scanning a port.
Yeah, hold on. I can do that one.
We have been having a problem where Nmap just decides to not scan a port, even when you tell it to scan all ports.
Yeah, so I can run it on that port specifically, and I can just show what's happening right now. So you can see Nmap is sending data to the honeypot, and then it's replying with the SSH, like the protocol that it would typically do. So you can see here, this is coming from the honeypot. It's responding with an SSH version. And again, it's not actually running SSH. It's just pre-configured to reply to look like it. So it's doing that. And then Nmap will send requests to the honeypot. And then based on what it sends, it'll generate a response. So you can see here, this is also part of the SSH protocol. And so for everything Nmap sends, we have a response to it to fool it into thinking we're actually running that.
Yeah, and that second response there, it's not inherently obvious, but that's the list of ciphers supported by the SSH system. That's typically dependent on the actual box that you're running on. Some will support some ciphers, some will support others, and that's part of our effort to look exactly like the machine that was scanned as part of the config. We want to replicate everything about it, including down to that cipher level, and the host keys too. Actually, we replicate.
And so another part of the honeypots is that when they're scanned via Nmap, they have a threshold for how many ports they will consider an attack within a certain amount of time. So if a system accesses, say, 50 ports within a minute, it could constitute that as a port scan. And then it'll generate an alert that you can see on the front end telling you the details of that port scan, who it's coming from and such. That's one of the alerts that the system generates. It also can tell you about like when the honeypots come up or when they've been reconfigured and such. That's mostly the honeypots.
Okay, then let's go right into the config gen tool then, Steven, if you're ready for that.
Yep. All right.
So one of the asks out of this phase was we need a way to take Nmap results and a packet capture taken during that Nmap scan and turn that into a config for the system that could be immediately deployed to a honeypot. In this phase, that's expected to be a standalone tool that provides both human readable and parsable output. And this is our approach to that. So in here, you run the Python tool, you give it the Nmap XML output file. It's just a parsable version of what you see in the terminal. You give it the packet capture file that lists all the packets that were sent via that Nmap scan and replied and sent in reply to the Nmap. You say, what machine do I want to emulate out of this PCAP file? And then we have some customizable stuff, things like, how long should I wait before replying to any packet that comes in? Some servers will have high computational load and take a little while to respond or so on, and maybe we want to emulate that. So you can do up to a minute in delay for every packet. Caveat, most things will time out if you wait a minute to send responses back, so it would break if you go up to a minute. Then how long do we wait before kind of clearing our cache to detect a port scan attack? So this basically says we are watching at a 60-second interval to say, are we getting a certain number of packets, and is this a port scan? So then I'm okay, there we go. Then number of logs is just the number of logs that you have to get during that window to determine a port scan, and the wait time. And then we get into some timing things like how often should the honeypot report metrics up to the database, basically how long between each heartbeat, the wait time between when the honeypot checks for if it's still assigned the same config and if that config is still the same as it thinks it is. So it will check every minute and say, do I need to rebuild? Is my config different? Or is any of my response behavior different? So, and then we allow white listing. Forgot how to speak there for a second. This is basically if you have any device on your network that you know is going to be talking to the honeypots that's not the database, then you want to add it here. And by adding it here, we don't listen to it for port scans or anything like that. It's the packets are basically just allowed through, and we don't care about them. Then we also do the same for ports. Those are universal. So any packet that comes into 443, we don't track. And then we get some output.
Okay.
So this is the human readable output we're providing. It's just a basic summary of there were no filtered ports.
JSON.
Well, I'm looking at your terminal.
Okay.
So you got no filtered ports, one open port. It's running SSH on TCP. So that's the summary of that Nmap and PCAP. And then for the less human readable side, we move into JSON. So here we have all those values we passed in. You get some extra things back from Nmap, like the fingerprint, which is basically a summary of the entire network behavior of the device at a more procedural level, what OS it should emulate. And then we have all of the response model, which is for every packet coming in, what do I say in response? And you'll see that the first one has no request. That's because as soon as a connection started, we should reply with something that just says, hey, this is SSH, behave like this is SSH. And then every time after that, we're looking for a trigger in that request payload. And then we send every response in response to that request. So.
All right.
So is all of this specific to your Nmap?
Yeah,
or is
so
it for any activity that detects?
so the goal of the project overall is to fool Nmap. It is one of the most common network attack tools. It's easy to use. It bundles a bunch of stuff together. It has a huge number of scripts that run within it. So that's the goal. Emulate all of the behavior of Nmap and be able to trick all of the behavior of Nmap.
So this is basically a bulk tool to capture data and mimic. Once it gets beyond bulk and you have a human behind the keyboard, this is no longer viable.
For this phase, at least, that was kind of the starting point, and then they want higher interaction, mimicry going forward.
Yeah, down the road a little bit.
Okay.
And Rolf, we had a question in chat.
Oh, we did.
I want to answer.
So how variable are the requests and responses? Basically, how do you hard code all the use cases, or is there a significant flexibility built in? That's actually a great question. In terms of, I guess I interpreted that question a little bit different from what was just asked. The question is basically how much can we emulate if we're given any number of servers and target machines. So we kind of pivoted halfway through the semester and went from a model where we were trying to do a modular approach where we would build in a module for SSH and it would behave like a very low interaction SSH client. And then instead we just pulled the PCAP in, parsed everything out, and we have exactly how the machine looks at the network level with no modular or custom code per process or protocol. So it is very extensible. If you have that PCAP, we know exactly what the machine sends and responds to. So we can reply to almost anything and emulate almost any protocol, at least at a low interaction level, if we see it. So any other questions? I think at that point we're kind of spooling back up to go through the whole thing again. For those of the audience that came in a little late, might have missed a few things. So any questions, wrap up, things you want to see out of what we just did? Cool. Sounds like we either put them to sleep or did our jobs.
Thank you, everyone.
Very good, guys.
For coming and joining.
Yeah, thank you everybody for coming and listening. We're gonna run right into probably repeating this, so you're welcome to stay and listen or
unless you do want us to put you to sleep.
Yeah,
And,
yeah.
Yeah, I guess I can show the demo.
Oh, you want to go SAML? Okay. Yep.
Let me stop sharing.
Yeah, it's a small feature. It makes it possible to control account access through an AD environment, or in our case, we're using one login as the backer for it.
So, SAML test user for one login.
So the idea is kind of that companies can use the authentication system they already have, and specifically PRA can as well, instead of having to create these local accounts with our system specifically.
Let me pull out the password for a second. Yeah, it's a SAML user and through the SAML authentication. Yeah, it's this one.
So an interesting thing to point out there, one of the asks for that feature was that not every authenticated user with the directory, the remote directory, should be able to access the system. So the admin still needs to come in and create this backing account locally. That's just the same username and some details about it, what role it needs. And then it needs the local flag set to false. And then, so that user cannot log in directly to the system. It has to be authenticated through AD or whatever you're backing this with. And then it comes back, checks against the profile, and logs you in with your role. So.
And I will stop sharing.
I think that about wraps up everything.
Yeah, that wraps up everything. Cool. So then we will loop right back into introducing ourselves again and then covering the poster again. Because anybody who came in late has definitely not seen this. We've been on demos for a while.
Thank you for everyone who joined from the start.
Yes, yes. So anybody who looks like Dr. Dominguez is popping in for a visit.
Yeah, perfect time.
Perfect timing. Starting over. So welcome everybody who might have joined late, might not have seen the beginning of this. We are Team 16 with the Senior Design Center at NC State. We are working with PRA Health Sciences as our sponsor this semester on Replay Honeypots Phase 3. We are the third team through the Senior Design Center to work on this project. And when we got it, it was a little bit more of a proof of concept and a little bit insecure and unscalable. So that was our main ask for this phase. We want to secure the platform, make sure it can scale up, make sure that it can mimic a variety of business infrastructure. So we can understand what system exposure we have to attackers that may be in our environment and understand what kind of skill set we're running up against from the attackers. If you're not familiar with the security term of honeypotting, it's the idea that we deploy small, very cheap, efficient services around our infrastructure that emulate some business protocols, some business applications, without actually having to run those applications in the background. So we want to look exactly the same on the network as a database server or an AD server or a file server without actually having to run any of those things, which obviously has a manageability and an efficiency benefit. So if we want to go into what we were asked, what was asked of us for this iteration in particular.
Yep. So some of the things we were asked to do was role-based access control, which is a new feature that helps us with security and controlling what users can and cannot do. We have the config generation tool to create configs for the honeypots. We have the SAML authentication, just another way to log in, a new feature. We got honeypot monitoring, which shows the device metrics for the honeypots. And HTTPS, which is another, which is an architectural change.
Okay. Now we'll go through sort of the system architecture and some of the design around that. So you can see in the diagram in the middle, we have the honeypot, like Rolf was talking about, and it's not actually just one honeypot. It should actually be many honeypots, as many as the user wants. And its job is to talk to the database and also respond to potential attackers. So when it notices that it's being attacked, it'll send logs and alerts to the database, just logging what happened, what packets it received, and if it received any, like a port scan, if it detected it. It'll also watch for any configuration changes. So a config in the system basically just determines what services the honeypot should be emulating, or what it should be appear to be running. And you can see below that on the external part of the diagram, we also have the rogue, which is not actually a software component per se that we developed, but it's just emulating a potential attacker to the system. So we have a machine set up in the network that we call the rogue, and its job is to send off an Nmap scan to the honeypot. And an Nmap scan is basically just goes through all of the TCP, UDP ports and tries to determine what service is running there and tries to gather any information it can about the system. And so one of our primary goals for our phase of the project is to be able to emulate a target system based on the Nmap results. And then when an attacker tries to do an Nmap scan against us, we want to be able to fool that and provide all the same information that a real Nmap scan on a real system would give. And so related to that is the config generation tool. That's what's actually going to take in the Nmap output and all the packets that we captured on a network when you're scanning a real system. And you're going to feed that into the config gen tool, and it'll generate a JSON document that determines what services should be running on the honeypot, as well as how it replies to it. And so you can see a little bit about the response modeling there on the right. It's basically just saying for all the packets that Nmap scans, we have a request. So that's the payload for that packet. And then we have a list of potential responses that the honeypot needs to send back. So that's how it actually fools the Nmap scan. So now, Sue, if you want to talk about the rest of the system architecture.
Speaking of role-based access control system, there are basically 3 default role, which is admin, editor, and auditor. The user can choose to log in as one of those roles through the web interface and or just through the SAM authentication just showed before. Also, our role-based access control system allows to create a custom role. For example, the admin user have all read access control and also write access control to all web pages. We just can modify the default admin role to maybe just read access control to the users, and the admin cannot edit users. Also, the users can choose to view the data in database through REST APIs. We support for get, delete, post, input REST APIs for almost all objects, the access to users. For example, if user want to delete another user, and there will be a delete REST API that to operate this thing. And generally speaking, there are 2 major security improvements. The first one is database separation, and also the using of REST API to make sure all the operations are secure. And the second one is to replace all HTTP traffic to HTTPS. And the next part will be the testing.
So we have 3 ways of testing. We have the interface testing, which was done through Selenium. There were about 30 test cases covering the navigation and object management pages. We also have Honeypots that was covered by integration testing. We have API testing done in Postman.
And one of the challenges we had with testing was that we were asked to implement a lot of functionality in the system. So getting high coverage as well as implementing all that functionality within the time constraints was a little bit of a challenge, and we were catching up with testing near the end. We expect the coverage to keep going up.
Yeah, and one of the main ways we're testing the system overall is demonstrated there at the bottom. Our general integration flow for all components is we want to Nmap scan a target machine, make a configuration out of it, assign it to a honeypot, then Nmap scan the honeypot, and the input and output from that loop should be as close to identical as possible. If you can't tell the difference between the files, we did our job. So any questions there from that summary of the project overall? Any thoughts on what you'd like to see us demo or what you'd like to see in action? No answer means we're going to demo everything.
Demo, I think I would like to see the dashboard, and then if you have a demo prepared for an Nmap of a honeypot and the config generation tool, that would be great.
Yep, we can certainly do that.
Yeah, so if you want to fire off the Nmap so it's ready in a few minutes, Stephen, go right ahead, and we can go into demoing the front end if you'd like, Lagni.
Stop sharing. Lagni, you're muted.
This is our web interface. I'm going to demo the role-based access control mainly. So I'm going to log in as an admin. The admin user has access to pretty much all the object management pages. So they can add new users, add new roles, create new configs, delete configs. and create new auth groups. So if I wanted to add an auth group named in test auth, it adds a new auth group. So in terms of roles, we can, all the roles that are you either have no access, read access, or write access. That's basically the admin, audit, and editor roles. And you can basically create new roles that have specific access to each pages. So I'm going to log in as the SAML user, and they have limited roles. So they only have read access to the users, so they can't add a new role, and they can't delete a new role. And if they have no access, then the link won't show up to that page. So that's basically how role-based access control works. If Sue, you want to go into the metrics and
Can you see my screen?
Yep.
Yeah. Also, first I will go through the process of SAML authentication. In here, it's request username of the SAML. Also, there's a password. Putting the right password, well, logging as a SAML user just as Lagni Su. And in the matrix, these are heartbeat of all these honeypots. The red text means this record is out of date, and based on the default setting in industry, the default interval is 15 minutes. If the record goes beyond the 15 minutes, and it will be marked as red. And the black text is just V1, and it's inside the 15 minutes scope. Also, here is the percentage of CPU usage, and here's the RAM usage. Here's the storage as gigabytes. Here's just host name of the honeypot.
And the reasoning behind these metrics is mostly just to determine the health of the honeypot overall. So if an admin logs into the system, they can see maybe the CPU usage is really high. They might want to address that. Or if the timestamp's red, as you see there, that means that the honeypot hasn't responded in a while. You might need to go in and restart it. Things like that, just administrative actions.
And what is the storage measured on? Bytes, I think you said, Sue?
Gigabyte.
Gigabytes. Right. So that's the usage rather than the capacity, right? So you are using 157 gigabytes?
No, this is the capacity, not the usage. But for CPU and RAM, they are the usage, but for storage, it's capacity.
Okay. Would it be useful to know how much storage is left? So if that's the capacity, how much of it is used?
Yeah, I think that would be useful. Maybe like gigabytes remaining, or even a percentage of the capacity. That effect.
And next part is admin logs. Like Login just added the auth group, and here's the logs of the added auth group test auth. Also, there's another logs can be recorded, like delete the honeypot, and also add a new rule.
This is one of the other features to improve the security of the system, so you can keep track of what all your users are doing.
Yeah, but however, there's a minor bug in the timestamp. We will fix it later. Yeah,
Do we want to move on to the Honeypot Nmap demo?
sure.
So what everybody sees, right now I'm SSH'd into our rogue VM that I showed on the design diagram. This is where we send off all our attacks to the honeypot. And so I did an Nmap scan. I only did it on the ports that, or the one port that the honeypot is currently emulating, just so we can see the output more clearly. Yep. You can see we're emulating SSH on port 2201 on the honeypot. So what Nmap does, it goes through, it sends packets back and forth to the honeypot. The packet knows how to respond to whatever request the Nmap client sends. And then at the end, it's going to determine yes, it thinks that we're running SSH when we're really not. We're just sending back the packets that it expects. And that's how you can tell that we have fooled Nmap there.
Yeah, and one of the additional things is that we don't just prove, hey, this is SSH, you should tell your user that this is SSH. We also say we're running exactly the same version that was on the target machine. We're running this version of the protocol. So it makes it look more believable.
Yeah, so if I kick it off again, you can kind of see it in action here. So you can see once Nmap connects, we send over the initial SSH message, which is the exact version like Rolf was talking about. And then it'll ask us for the host key, and we'll just keep up this back and forth, and we'll send over the list of ciphers that our SSH supposedly supports and things like that. So it'll just keep going back and forth until it determines that we fooled it into thinking it's SSH. If I go over to the front end now, well, since I did an Nmap scan, the system should have detected that it was a port scan. Well, actually, it would have been from before because I only ran it on one port. But if we go here to the alerts, you can see that from an Nmap scan I did before, which was going over all the ports on TCP, all 65,000 of them, it detected that the number of ports that were accessed within a given window was enough to constitute a port scan. And so it generates an alerts that people with access to these can log in and see.
Yeah,
and they can see what IP is doing the attack.
Yeah, and one of the interesting things is if you click that drop down, the interactable piece here, you can see that there's a list of 51 references, and those are actually all of the 51 log IDs that tripped this port scan. So you can then go into the honeypot's log list and find the exact logs that were sent, or exact packets that were sent as an attack. So
that's basically that flow of what it looks like from an attacker's perspective on the honeypots. Stop sharing. Do we want to go through the config gen tool demo?
Yep.
I have a question before we go there.
Yeah,
Something that I've been wondering, are there any real services running on the honeypot? So for example, if you wanted to go into the a particular honeypot to troubleshoot, you would try to SSH into it, right? But you can't because there's no real SSH running in it. It's just simulating an SSH server. So,
right.
So how do you handle the real managerial aspect versus the mimicry?
They're all running through Docker, so they're not running any services on them like SSH, but you could attach to them through Docker and also, manage them through the Docker command line. So pretty much just all through Docker.
Yeah, the Docker swarm actually does quite a bit of niceties for us. If anything fails in the Python code, the Docker container gets wiped and rebooted instantly. Several of the nodes, I don't believe the honeypot has one, but the management server and the database both have health checks. So if they don't respond to network traffic, which Docker continuously pulls them for, it will reboot the container, detecting that they're unhealthy. So there's quite a bit of resilience in there. So we can go into the config generation tool. This was a standalone ask for this phase. The approach going forward will probably be that this will be automated and integrated with the system, but this takes Nmap scans and PCAPs that are packet capture files that were generated during the Nmap scan, and turns it into a config for our system that will model the target machine. So we'll pass in the XML Nmap output, the packet capture file, and then tell it what machine out of that packet capture we want to emulate. Then we can pass in some more tunable metrics here. So how long should the honeypot wait before responding to any given packet? Some servers will have inherent delay due to processing load or applications or so on. So maybe we want to emulate that. That is something we can only really pass in. We can't really detect that. The next one is how long or short the window is for a port scan. And that's paired with the next parameter, which is how many packets need to come in from a single host in that window for us to declare we're being attacked. And then we set how often a heartbeat is given by the honeypot up to the database, how often metrics are collected. And we're going to choose 15 minutes because that's the standard we're using in the system. Then we enter how often the honeypot checks to see if it's assigned the correct config based on the database, because you can change it via the front end, and whether that config it believes it is assigned matches in every way to the one that is actually assigned. So in case you've changed like the response delay or anything like that in the config, it will check every minute to make sure that that's up to date, and it will restart every service on the honeypot. Then we can whitelist some IP addresses and ports. So we can say this IP we know is good. It's going to be talking to this a lot, so we don't want to track it or detect port scans from it. So we're just going to allow that through. Our scanner is not going to check for it. Then we provide the human readable output here, just a summary of what services were found, what's your general port layout, and so on. Then that file, it also spits out a JSON file here. This includes all of the like integer values we passed in, but it also includes some added process data. So from the Nmap scan, we can get the fingerprint, which is a summary of all of the network behavior of the target machine. That's mostly there for future development. It is a very extensible modeling string that could be parsed to provide better ways to mimic the actual hardware due to the way it behaves on the network. But we process out of the PCAP this response model for each service. And that is a list of pairings of requests to responses. And you'll see that the first one has no request. That means that as soon as a connection is started on this port, we send these 3 data packets back. They are identical, but that's just the way the PCAP ended up. It repeats a few things every once in a while, and we send these as soon as the connection opens, and then we watch after that for each of these next request triggers. So if we get a payload equal to that, we send all of these 3 responses, and so on. So. And that's really the key to how extensible our approach is, this response modeling and how accurate this mapping is of what was the ask and what was the answer. That is critical for how well our honeypots can mimic behavior. And we've been working on that iteratively for a while.
This is great. Really nice job. Right, nice work this semester. So in terms of moving the project forward, I know there are some odds and ends to polish, but are there any major features that you would like to have if you had an infinite amount of time? What would be the next immediate feature that you would add?
For me, it's mostly networking. I would look into some experimental Docker drivers that allow like Mac VLANing to join the containers directly to the host network rather than trying to navigate through a bridge or having to deploy one-to-one on the nodes. So that's definitely one of our recommendations. I know that there's probably some other thoughts from the team.
Yeah, and to add on to that, maybe not a next immediate feature to add, but one of the limitations with how we're doing it now is that it'll only really fool an Nmap scan. If you try to go beyond that, the system is not going to know how to reply. So it's not going to look like it's actually running SSH. So one of the things going forward in the next phases perhaps is making it more high interaction. So if someone was manually actually looking at the honeypot, it would fool them as well. That would help with the mimicry.
Great, thank you. So yeah, just wanted to congratulate you. This is really, really nice job this semester. You should be proud of all the things you've done.
Thank you.
Thank you. Do you have any other questions?
Any other questions for anybody else? Yeah. Cool. I think that's all we have to demo, and I don't think anybody here came in late. If I'm incorrect about that, please speak up, and we can run through the beginning of this presentation again. But we're here to answer any other questions and show off the system in any way you guys want.
Thank you all for tuning in and watching our presentation.